So in this video, I'll demonstrate the process of completing problems using dimensional analysis that involve the mole. So recall, the mole simply tells us the amount of substance that is present, and we can compare anything to the mole. We can compare the mass to the mole, we can compare atoms, ions, we can compare molecules, so we can compare basically anything to the mole. And so in this video, I'm going to look at the last two problems from the Chapter 2 homework and use those as a guide to demonstrate the process of using dimensional analysis that involves the mole. And so the last two problems, they each have two parts, but I'm only going to do the first part. And then by showing the process and explaining it, you should be able to apply that and complete the second part. So one thing before I do start with the process, with the first problem that I'm going to look at, we have what is the mass of 3.83 moles of bromine. Bromine is a special atom, so if you notice, it only tells you the name. So I think we all know that bromine is Br on the periodic table. But one thing that you may not know is that bromine is one of the 7 diatomic molecules. Diatomic means 2 atoms. And of course, we know that molecules indicate that we have 2 or more atoms that are chemically combined. Those atoms could be the same or they can be different. So what that means is that for those 7 diatomic molecules, they naturally exist as a molecule. Even though we only see that one element or that one atom on the periodic table, they naturally exist as 2. Those 7 are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These are your 7 diatomic molecules. So whenever we simply say hydrogen, it really exists as H2. This is how they naturally occur. So you want to make sure that you pay attention to that, because here it just says bromine, but it's really Br2. So that's going to be important in helping us determine the mass in 3.83 moles. So now we'll go through and work the problem. And so with this problem, anytime you're trying to use one unit to figure out the value or the equivalency in a different unit, that lets you know that you're going to be dealing with dimensional analysis. Recall, dimensional analysis is simply another way of saying conversions. But in order to do that, we need to show how units are equivalent to one another. So we need to show or use conversion factors. And so with this, you want to think about your steps for dimensional analysis. First step is to identify what's given and what's needed. What's given in terms of units are the mole. What's needed in terms of units is the mass, which would be the gram. So then you want to ask yourself, is there a direct relationship between the mole and the gram? So is there a direct relationship between the mole and the mass? And there is a direct relationship. That relationship is known as the molar mass. Recall, the molar mass tells you the mass present in 1 mole of a substance. It has the units of grams per mole. So that lets us know that we're looking at something or 2 units that are related. We're looking at something that we can use to show how the mole is related to the mass. And so in order to calculate the molar mass, we have to think about the actual formula. So again, it's not just Br, but instead it's Br2. So we have to use our periodic table, which is going to allow us to determine the average atomic mass for each individual bromine, but we have to account for both of those bromine atoms. And so when you look at your periodic table, bromine, which is atomic number 35, when you look at the periodic table, it has an average atomic mass of 79.90. That is the atomic mass for each bromine. But to calculate the molar mass, we have to account for the fact that there are 2 bromine that are present. And so we'll have to multiply that by 2. But recall, the difference between the molar mass and our molecular mass or molecular weight are the units. And so molecular weight, molecular mass, formula weight, formula mass, whichever term you prefer, they have the units AMU, atomic mass unit, whereas the molar mass, the units can only be grams per mole. And so because we had 2 bromine, each one has 79.90 grams per mole. That means that the molar mass of this bromine molecule is 159.80 grams per mole. So that tells the relationship between the grams and the moles. So the way that we read that is the same way that we would show it as a conversion factor. So 159.80 grams per mole. So I can show that as 159.80 grams per mole. Now I can put an invisible 1 here if I want. I can leave it without showing the 1. But if you put something there in front of that mole, just make sure that it is a 1. And so for every 1 mole, that's equivalent to 159.80 grams. So that is our conversion factor. So now we're ready to set everything up. We're now ready to use what was given as well as our conversion factors to convert from our given unit to our needed or wanted unit. So again, we want to start with what was provided. 3.83 moles of bromine. I like to focus on the unit initially so that you can make sure it's set up correctly, because sometimes you may write your conversion factor and it's written the opposite way of the way you're going to actually use it in your dimensional analysis setup. And so by focusing on the unit, you can make sure that you are setting everything up so that the units cancel that you do not need. So I need to get rid of the mole. So since it's already in my numerator, I'm going to put it in my denominator, but I need to go to the grams. By doing this, you can see that your moles will cancel out to leave you with grams, but don't forget to put your numbers in. For the molar mass, it's always 1 mole, and then we're indicating the mass of that substance present in that 1 mole, which we've already determined was 159.80. And so once you have this set up, you'll then carry out the calculation. And so in your calculator, you're going to have the 3.83 times the 159.80. Your calculator is going to give you 612.034 grams. If we're reporting it based on the rules of significant figures, we were only provided 1 measurement. It had 3 significant figures. We were only multiplying and dividing as we set up the problem. So our answer should have 3 significant figures. So 612. But then we have to look at that next number, which is 0, to determine whether or not that 2 remains the same or rounds up. Because the next number is 0, that 2 will remain the same. So I would show it as 612 grams. You can show it with or without the decimal because it's still going to represent 3 significant figures. So that's how you convert between the mole and the gram. We could have done the same problem if we were given the grams and then needed to determine the moles. The difference is that our conversion factor will be flipped the other way. But we will still use that molar mass anytime we're going between the grams and the moles. So then the next problem asked how many moles are in 86.5 grams of pure aluminum. And so again, I'll do the first part. The second part of the problem asked you about how many atoms. I changed it. I'm going to do the second one for this one. The first one is essentially the same as what we just did, going between the gram and the mole. It's just now we're going in the opposite direction. So you're still going to use that same concept using the molar mass because we're comparing a mass, which is grams, to the mole. However, with the second part, it's asking you about the atoms. And so with that, you have to think about, again, mapping out the process. So with this problem, now we have to think about the fact that if you're given the grams, I'm going to write it above, you're trying to go to atoms. So then you want to ask yourself, is there a direct relationship between the gram and the atom? And there is not a direct relationship. So I cannot go straight from grams to atoms. So then you want to think about, what is there a unit that they each have in common? So is there a unit that does have a direct relationship with the gram, but then at the same time, it also has a direct relationship with the atom. And there is. That unit is the mole. We have a direct relationship between the gram and the mole. We also have a direct relationship between the mole and the atom. So by going to the mole first, it allows us to go from what was given to what's needed. So again, going from grams to mole, it's going to be our molar mass. And the molar mass is telling me how many grams of the substance are present in 1 mole of the substance. And then going from moles to atoms. Remember Avogadro's number. So we can compare everything to the mole. When we compare the mass to the mole, it's the molar mass. For everything else, it's going to be Avogadro's number. Avogadro's number compares everything to the mole except the mass. Avogadro's number tells me how many particles are present in every mole. Those particles can be atoms, as we have with this example. They can be molecules. They can be ions. They can be anything except for the mass. So we now know that we're going to need 2 conversion factors. Recall when you're mapping it out, everywhere that you have an arrow represents the presence of a conversion factor. That is how we go from start to finish, or from one unit to the next. And so we're dealing with aluminum here. And so for aluminum, this is not a polyatomic ion. And so we're able to simply use the Al for aluminum. So now that we have our map, we know our formula, we can go ahead and proceed to set up this problem. So again, we have to go from the gram to the mole to the atoms. And that's what we just determined. That is our map to show us how to go from start to finish. So you always want to start with the measurement provided, which is your grams. 86.5 grams of aluminum. So if you notice with these 2 problems that I'm working, not only did I show the unit, but I also showed what we're dealing with. So in the previous example, I also showed the formula for bromine. In this example, I'm also showing the formula for aluminum. That way you can keep track of what is going on. And so in order to go from the gram to the mole, I need to get rid of my gram. So I'm going to put my gram in my denominator. I need to go to the mole, so I'm going to put the mole in my numerator. This allows my grams to cancel, so that I'm left with simply the mole. Again, you want to refer to your periodic table, and aluminum is number 13 on the periodic table. So if you look at the molar mass, the average atomic mass on your periodic table, since this is the only thing that is present, this is the only thing that will be used to determine that molar mass. The mass on the periodic table, that average mass, is 26.98. On your periodic table, our AMU, which in this case would be the formula mass, if we simply change the unit to grams per mole, it becomes our molar mass, or our conversion factor. So for this problem, again, by focusing on your units first, you can make sure you're setting it up correctly, because the way I have this conversion factor written is not the way I'm going to just plug it into this setup. Because if I put the 26.98 grams up top, my units wouldn't cancel. I need grams on the bottom. The number still stays with the unit. So I still have that 26.98 with my gram, and I still have 1 with the mole. Again, when you don't see anything, that means that there is a 1 present. So we can show it as a 1, or we could have simply left it blank. My recommendation is to not leave it blank, so that you can make sure you're not confusing yourself later, so you'll know that you already dealt with that piece. So you can stop here, but again, my recommendation is to continue on, because if you stop here in round 2 soon, you could throw off your final answer. So now we need the next part. So we've just done this first part of the process. We've gone from grams to mole, but now we need to go from moles to atoms. Again, when you're comparing a type of particle to the mole, Avogadro's number is what we have to use. His number tells us 6.02, or you can do 6.022. times 10 to the 23rd. In this case, the type of particle present would be the atoms. And it's always atoms per mole. So atoms compared to 1 mole. So again, if I focus on my units first, I'm going to have moles in the denominator because they were already in my numerator. I'm going to have atoms in my numerator so that I'm canceling out what I don't need and I'm left with what I do need. From there, I'm going to put the number in. Just as with the molar mass, when you're using Avogadro's number, it's always 1 mole. And then we indicate how many for the molar mass, grams, or for all of the others, Avogadro's number. And so now we have it set up. So from there, you want to actually perform the calculation. Because we are using Avogadro's number, this number is very large, scientific notation. When you're plugging it into your calculator, you want to be very careful. So you have 86.5 times 1 times Avogadro's number, 6.02 times 10 to the 23rd. When you put Avogadro's number in your calculator, my recommendation is to put it in parentheses so that your calculator knows that that entire number is being multiplied by 86.5. Once you get the product of your numerator, divide it by the product of your denominator. So just that 26.98 divided by 1, which of course is still 26.98. Once you do that, the calculator is going to give you 1.930059 times 10 to the 24th atoms. If we're reporting it based on rules of significant figures, our measurement only had 3. So we would simply round this to 3 and we would report it as 1.93 times 10 to the 24th atoms. So what this tells me is that when I have 86.5 grams of aluminum, that's equivalent to 1.93 times 10 to the 24th atoms. So I hope this helps. Feel free to reach out if you have any additional questions. And again, I hope that this has helped. Thank you.